the first thing to go today to finish this our section before we finish the first half of the class. So what is the goal? Again, just to remind you a little bit about estimation. I guess over the weekend, probably cannot fully remember what we covered last Wednesday. Estimation, and this is the goal of this is because of we collect data. We want to get an idea what's going on in the population. First of all, we are able to get all the data available that we want. Public mind. Also, we have to collect only some of the data. The time and money, everyone, money, income is changes. How many people like the viewer, any other stuff, right? People's preference change, right? It's good now, but they become people will like after. Okay, so that's why we need to do some estimation. Just remind you this. Get clear about me and then purpose. Most of the time we care about that. And also we care about the process and students. Of course, we just care about mean and varies because that's basically what we estimate more and told her to do it, but how to do it better will depend on terminology system, you can't say what is estimator and estimate. An estimator is something that is a random variable. Okay? That's basically based on the data, the input, how you find it. And there are two different types of estimator we consider. The first type is called bond estimator. Point, the number. Okay? And interval estimator that usually is not given a number, but usually two numbers. After the minimum, say a number will be interval. Even number, but interval with the two numbers. And indeed, you have, let's say, anything between two of those. It just remind you the point estimator that two criteria. One is for unbiasedness, which sets the average given time. It's about the sample mean. What is unbiasedness means? It means that if you do the sample mean, okay, for one sample, and then one sample mean, yeah, you do a sample mean. Then average of all these potential samples actually population mean for that. And second, identity necessity, which only applies to unbiased estimation. Okay? Only if you are unbiased, you can talk about it. Okay? So we will be looking at the careful and bias. Okay? One variant than the other. More accurate, and consistency, the clinical requirement, which said is very similar to the idea of unbiasedness. But unbiasedness is talking about you collect many samples, and average of those samples, okay, for those estimated samples, that it will be exactly what we want. But here, consistency is a little bit different. Instead of talking different samples, talking about one single sample. So what we're doing is increase the sample size. And when the sample size getting larger, what it means is okay, the sample, the sample mean. Okay, if you adding more and more random samples, okay, at the end your sample mean exactly as close as to the population as you want. But you can say that sample because a random variable, so we have to put probability here because we're talking about getting sample size bigger and bigger. When you utilize the notation, different. Because to get exactly this number of receiver, right? We learn the idea, we learn the use random variable, we know that. So that's why we have to using this rather complicated notation means the distance, right? Bigger than any positive number. That is what the content represent. Okay. And we have said the sample mean and sample variance are good estimator because they are biased, okay, and also efficient in some way. Okay. We're not going to do any proof on that. So next we talk about sample proportion. Sample proportion is that the sample mean, okay, is in the final data, which is 0 and 1. The case is saying as sample proportion, right, because it's 1 and 0. Okay. And the sample mean is exactly okay. And this is also an unbiased estimator, so that's a good estimator. So just to remind you why you want to be unbiased. Unbiased means that there's no reason to estimate higher. I just like why sample mean is unbiased means that you've got the data, collect the sample, you collect the sample mean, and this will be your estimate of the risk. You have no reason to estimate higher. Comes to the statements. And population variance, I think I talked a lot of time. I focus on bias. We're going to explain why we use it. The reason why you see actually a competition I keep our buy easy, so that's why we don't adjust. But this is a bias estimator for this item. Okay. Although to estimate pi, okay, P is the unbiased estimator, but anyway, we just use it. Okay. Now let's get back to the very important idea about people estimate. What is the idea behind the estimator? The main thing is that instead of making a guess on one number, we want to say an interval number. Like instead of a gun, we want to give, right? We want to have a song there. So we want to add more area to add more range, and we are more likely to hope to get. Right? You know, suppose we have a continuous random variable, right? The probability that the random variable exactly equal to the population mean, right? How is that you want to estimate to receive, right? But you want to get some more information, right? Based on the sample information by sample. So that would be we have knowledge about the signal, right? And then we have no more, right? Because the first thing is, say you're talking about sample mean, focus on sample mean here. Okay. And we know that the sample mean, okay, according to central limit theorem, okay, suppose we know signal, okay, we follow a normal distribution, okay, mean mu and sigma slope, okay, and the sample mean, the signal is an n, right? So it means that the more n you have, okay, the smaller variance. Okay. So one thing of this, one thing of this is if you have two samples and one sample size is that high, okay, and both samples you got the same sample mean, okay, both of them you got the same prediction. You use one method, okay, but you would say the sample that have higher sample mean to be more accurate, right? In the sense that the variance is supposed to be smaller, right? So the prediction, you would put more, you have more confidence on the prediction that based on larger sample. So how would you quantify this? Would be you are saying that interval. One, you have a smaller, bigger sample, okay, because you have more confidence, right? Because the sample mean that comes from a large sample, that's according to scientific theorem to have more, right? So you would be saying that I would be willing to say using a smaller model, right? Because it's more accurate, right? And after case n goes to infinity, you don't really need an interval, right? The point estimate would be something, right? Only when the n is small, then you need a bigger n. So just to repeat what is interval estimator is asking the following question. Before we do the sample, okay? We consider the following thing. Okay? We are going to try to say, depending, regardless of what the x bar is, okay, sample mean has not been done, okay, because we're trying to say, whatever we estimate, we figure out, we subtract m and plus n, okay, and we're asking is what's the problem? The problem we want the probability that this interval include the true mean as a high probability. Okay. The other word is I don't know what the sample mean is. Okay. I want to say, okay, whatever I figure out, okay, I just add m to the left hand side, m to the right hand side. Okay. I want this interval, of course it's a random, depend on what the sample mean is. Okay. I want this interval on 05 or for 01, it's like we want 95%, 90% or 9%, okay, of this interval, which is random. Okay. With random, remember the n is a constant, n is a non-random, okay, n is non-random. The x bar is random. But I just want to say, okay, that I can't relate this non-random, but where I land on depends on space time, okay. But what I want is I want no matter where I went, okay, I want 90%, okay, 95% or 90%, that will include the two. This point. That clear you? Okay. Let me repeat because it's so important. I want to understand this concept again. So what we want is we are going to estimate true mu. Okay. And what we actually get is x bar. Okay. Now consider the case where before we do the sample. Okay. X bar is a random variable. Okay. What we want is we want to have a non-random constant m for the number. Left and the right, okay, of the sample mean you got, okay, and we want this interval include the sample population mean mu with very large probability, okay, maybe 90%, 95, or 95. So how to figure out this? Okay, this M is doesn't depend on what sample we got. Okay, it's one method. And how we do it because that is coming from the central limit theorem. Okay. At the end of the day, we will see M is indeed somewhat is what you expect. Okay. The fit is very simple. Okay. This is the variance of X bar. Right. Central limit. This is the variance. It's just saying that we are going to say this is how variation of it. Okay. We will just multiply by this coefficient. This is something equal to something like 2 or 1.6. 1.72. Okay. It's like a multiple of the variance. So estimator, okay, for me will be, I will be looking at sample mean, okay, and but all like 2 times of the extent. 1.5, 1.6, depending on how likely it was. Okay. The proof is rather simple. Just let me repeat again because I think I will repeat it because it's very important. I apologize if you know it already, but I just body that will be repeat again. So this Z is normal CO1. If it's normal, okay, and we know how to calculate what is probability that D is within plus C and minus C, high probability. Okay, just to remind you a bit how to do this because I think this proof is important. Maybe I just talk about this again. Normal, the bell curve. Okay. Here, what we want is I want this purple area have probability 1 minus alpha. Okay. If alpha is 0.1, then it's 90%, right? Alpha if we put 0.1 means 90% or probably 0.9, that is within this range, right? So we want, and this is we want it symmetric minus C and C. Okay. And we know that if it's standard normal, what is the C that are standard R? The definition is the following, right? This area is R over 2, okay? And this C is we define as Z. Okay? And you put XL will be norm S inward alpha over 2. Okay. Number there. This number is either alpha is say 0.1. This number will be 1 for we can set it as easy, right? The calculation is we will talk about it in example. And because this number, right? And we know by central limit of this guy is standard normal. So by rewriting the equation, we multiply this and 2 plus minus X bar, I think that is common. But the key here you can see, okay, the non-random margin, right? This margin is non-random. This margin left and right is non-random. That doesn't depend on X bar. Okay, it will depend on sigma and also we know, right? This N is we know, we fixed it already. So this is also everything non-random. So let's see an example, and before the example, this definition. Okay. So this guy is called margin of error. This is the M, small m we have patient, and go left by n. That's why the width 2 times of it. Okay. And you may say it's rather trivial here. Why we the width 2 times why we call it the 2 terminology. Because here with bell-shaped curve, left and right is symmetric. Okay, and if you try to ask, don't do it now, but or did in this class, but you try to construct a combinable for variance in our class, and you look like high square is left and right are symmetric. In that case, the width will not be 2 times the volume. So the smaller area left and right will not be symmetric. Okay? But, here we follow the textbook, okay? Just even in this single case, limit, right? The lower limit, upper limit, right? Just adding margin. Right? You look that this is all the end points. Okay? What you're doing is anything in the middle, you can't say which one's more like every number. Don't put probability particular where it's more likely, which is less likely, but how. Of course, it is under our condition, it is very likely that the most possible one is the middle. That is the middle is the most likely, and you go to 2 sides, less likely. According to the idea of the bell shape. Let's see an example. I think that would be useful. So again, this is my example, but we never look at it. But of course, you may say there are some scenarios with no set because we actually may have consider a point estimate. Okay. So good idea. Anyway, next to the Theorem, I think we know it. We do a random sample and with the sample size 64 and sample mean with 4. Okay. So with this question, we know sample mean is 4, and the point estimate, which is the sample mean, okay, is unbiased point estimate. And the question is, we want to come to a 95% confidence, which means alpha is 5% or 0.05. Because 1 minus alpha, so asking you for this guy, that's 1 minus alpha, okay? So which implies alpha this is 195 alpha is 0.05. Okay. So what we are doing here is to find a z alpha over 2. Okay. This is. And then we want y is at 1.96. Remember, this guy is log s inverse 1 minus alpha 2. So let's show you the Excel. How? Okay. So it will be norm s this inverse 1.975, right? Because alpha 5 alpha 2 is 0.025. 1 minus 0.025, but if you don't want to do it so direct, you can just do this 1.05, right? 5%.
divided by 2. This is answer then. The answer. Now, if you, since we are in the lab, so let me also show you our code as well. So, to calculate that one would be very simple. We use Q norm. And the same idea is 1 minus 1005. That will be the same answer. If you can see.
Regardless of pixel or how. Q norm is just the 1000 norm.
I hope that's okay. Any questions? Know that we are going to here, go back to here. We now know how we get 1.96. Let's do briefly, very briefly remind you this formula. What it's doing is talking about this is 195. That means the blue area 975. Okay. So this number is exactly
Below 0, right? So then we keep below the margin of error. The margin of error, we just this coefficient multiplied by the variance of x bar. Okay. Variance of the sample mean.
variance sample mean, remember, is what? This guy, right? Variance sample mean just sigma over root n. So the standard error
of the sample mean. And this is 4. This is 64. So it's 1 half times 1.96. Right. The margin is by 1. So the sample mean is 3. So we go left by 1, go right by 1. Okay. So we have the good confidence that is between 2 and 4. Okay. Margin is 1. So just to remind you why we call probability. You can say probability before you do the process. Okay, because it's a random variable, you can assign probability. Okay. But the problem is once you have found the data to the calculation, it's no longer probability, right? Because it's either it's in or not in. Okay. There's no probability. The probability is only for you can assign things that have hasn't happened. Something happened. There's no problem. Like I have a coin here, I close it, right? There's a half of it is a tap, right? But after I close it, there's no problem. Here's the coin, right? It's like head and tail, right? Then you can say after my close, half head, half tail, right? But now suppose I do it, there's no more probability. It's either head or tail. Just don't know. Right? They only have one direction. Right? There's no more probability. Stay. Okay. But of course, you still get like your 50% confidence is head, 50% confidence is head. Right? Same here. You will say 95% confidence that is between 2 and 4. Okay. And the confidence is in the confidence in the procedure. In the sense that it will be repeated procedure where we never do it. Consider case of repeated procedure. Okay. And we will say 95% of those intervals will include the true mean. Okay? But you don't know which 95 or 100 of them. Okay? But that is the a very subtle terminology. So that's why, okay, that's the confidence in that approach. Just to remind you, you only can say confidence, but you only can say probability for event that haven't happened. Either you have had or no probability. Now, the next is the sigma is have to be low in order to calculate the interval that in the last example. And we know that sigma is never known. So how do you able to estimate the income, right? Maybe you don't know. So what we're going to do is to use the sample variance to proxy to pretend it's going to say. We know that that is a key. So basically everything goes through, okay? And the consequence, actually you know it. What the consequence is let's go to the next slide first. Okay. The consequence that everything is the same, but you have a equal coefficient. Okay. And if you still remember what P and that is share both values. Okay. The measure on both sides. Okay. What is P is you take a normal. Okay. The camera, the middle, say thumb the bell, and thumb in the middle and both sides high. Okay. And both sides higher means that if you want a probability 5% or 5% both sides, right? In that case, these numbers are high. Why? Just to remind you why it's the case. Let's draw a picture and use it. Okay. Remember, suppose it's a bell shape. Okay. This is okay. And what is T here? T is the one that has a hammer at the top. Okay. So remember it's something like that. Lower. Okay. But do remember that they are distribution. Okay. So the area below must be 1. Okay. So you hit the top. Okay. The two sides are higher. So that's why we say just hit the top and the two sides go up. Okay. That what does that mean? It means that if I want, suppose I want this area for the red one to be 1 minus alpha. Okay. So the two sides will be alpha 2. What happens to the blue one? Okay. This is Z of alpha 2, right? So, and then we say this is P. Okay. What will be P alpha 2, right? Will be further away. This would be alpha 2. This area is only alpha. Go further. So which means that if we have no idea on the sigma, we use S. It's not a sigma. Okay. Let's actually we see before we have 1.648. This one will become much larger. 10 of n. Much larger. Sometimes 2 is beyond 2 sometimes. Okay. So basically the idea is if you don't have sigma is S, okay, you have to multiply a much larger adjustment. Okay. Now I'll give you an example. What happened is example again, if the sample size is size n equals 20, sample is 3. And now we have to rely on S because we don't know sigma. Okay. But this is the case where this is very realistic. Okay. going to collect the sample income, right? For the data. And we try to estimate the confidence interval. Okay. So we have sample mean, is 3. And then how to calculate this guy, right? Because no longer use Z with T. Okay. So this guy is what? This guy is P n minus 1 over 2. Okay. And this is, right, remember 95%? For 95 is 1 minus alpha, imply alpha is 0.05, right? So alpha over 2 is 0.025, and n is 20. Okay. And how to do this? Is just P inverse, right? So how to get this? P inverse on 975. And you repeat them 19. Show you P inverse 975, 19. Okay, so this is 2.9. So you can see I expect this number is okay, because you are less sure because this it depends on the S, right? So if you have S, that means that S can have a mistake. So we understand it. Okay, because S is estimate from is not actual one, so it can be larger. You'll be large. 2.09. So how to do it in the R? That's the same thing. Now you don't have QT, right? 1 minus again this, and do the same, following the same terminology, but use QT. Run it. 2.9. Eventually, you can see it. So you the inverse. You can say inverse of take the same notation. The probability you want to estimate the right hand side, the left hand side probability of it. And it's kind of same input. It's P dot input. Now, there's the same thing here. Okay. We will multiply by S over root N, right? This is the estimate for the variance of what we have 12 over root 10. So you can see this pretty large amount of error. And then you will see what we have will be otherwise almost 76, right? 5.6. The 3 here at the end you can have negative number and positive number. And this can actually sometimes make sense. Right? The negative number. When we talk about income, then probably this number will not be very good. Right? You're saying that average income 3,000, 300, whatever, hourly wage, whatever, right? And at the end, you've got a negative estimate. Okay. So this is not really desirable. So there are one way or the other to do it with the N so that you get more accurate estimate. Otherwise, it's not really get something negative. course, you are able to get the data more, what you get, and business estimate not using this. X cannot be. There's no way you can be below zero. Then it's just like saying this interval estimate of the assumption of saying X bar is a normal. It cannot be below zero. So anyway, that will be for advanced classes how to deal with those situations. So I suggest if you have a negative percentage, okay, just have it. We don't have anything to say right now. If we really want to go further, we should analyze. I mean, this means that it's not a good model. So we need to have something else. But anyway, we just happy with that at the moment. So before we break, just maybe a few more minutes because I will finish this set of slide. This is one of the case slide. We exactly the same thing. Okay, so don't worry, we do exactly the same thing. You remember that when we have proportion data, binary data, we have just said P times minus P variance. So this guy is the measure the standard deviation from this. Still remember? Let's get back to the slide. So we have here, you remember this guy. This guy is normal. And we estimate this by replacing it by. So that's why we have to follow. Let's do this. This is the whole. This is the variance of this guy. So we pi 1 minus pi. But now pi. So this one would be using the normal. We don't use P here. The reason is because this is the classical way to do. Okay. Try to check the theta on one textbook. They will say this can be problematic. This is only good approximation where both n here and n are pi. And you notice that there are a lot of complaints in this every feature. Okay, but all the introductory textbook is this one. Of course, you should know it. This one is a little bit problematic. First thing I would say, this is not a good estimate. This is bias. But do you know that when n is fake? Look at this. This is zero. When n is fake, and t is not that small, like this. And the t around say 1.4 is a middle range. If t is very small, this is the problematic. So that's why you be very careful. Okay, for business application, you shouldn't be a big issue. P usually not that small, right? It's not mathematical idea, right? Pandemic or the virus, those kind of things. But estimate how many people were infected. Now, in cases, you take this. But this, to remind you that that's why we need that must be at this. Okay. But they get at least we can certify this. But even certify this can be sometimes. But anyway, this but all the textbook using this. So this we don't want to go against the division. So this is we follow this. So that's the example. Then we have a break.
Okay. So it's very simple. We just follow the same procedure. Okay. We have a single random sample with sample size n equal to 64, and sample proportion is 0.3. Okay. That means that you have okay, this number. Okay. How many of them? Okay. And now what we're going to do is the point estimate. Okay. We just same as your sample proportion. Right? You are estimating the population proportion pi, okay? And this will not 95%. Just again, 1 minus alpha is 0.95. Okay? So that's why alpha is 0.05. Okay? And alpha over 2 is 0.025. So this number. This I'm not going to repeat in Excel. Norm S inverse 0.975. Okay. I'm going to repeat this Excel. Okay. The only important thing is this guy. Okay. For P, for the proportion. Okay. The notation will be, remember, it should be like this. Okay. This is the standard deviation for the sample mean, right? But we use this to estimate. We use P, 1 minus P over N. And this is turn out to be 0.112. Okay. So you can see you have proportion 0.3. Okay. But it's around again 2 and 4. And you say it's not very precise, it's too big. Right? I want to get 0.3, but at the end I estimate 0.2 and 0.4. So what we want at the end is we want to get more at the end. Okay. And after the break, we talk about the other way. Here I have P and the N and capital M. Okay. On the break, we reverse it. Okay. Suppose I want, before I do it, I want to achieve certain M. What is the M? Talk about this. So that's the break. And it is a new complex. Or the question. All right.
俾解下啊嘛，如果唔係都係呢個數學嘅係好啊，你明白嘅數學都係佢唔有成幾個。
Hi. So the next one we'll be talking will be this. I hope there's no question. So there will be last one. So so far we have been working on is come on the problem and find an interval. Okay. So the question is, we go one step backward. Okay. We want to see, suppose look at the answer first. I want to achieve a desirable margin of error. Okay. So what should be the sample size? Okay. It's because we want to have a sample size desired at the beginning, right? We do practice. Okay. Everything will be collected in the middle, right? But the sample size is something we can decide. Okay. So the question is, suppose you want to achieve a desired margin of error. Okay. So what should be my sample size, right? That is, you decide at the beginning of the survey how many people you're going to do, right? So that is a very practical question. Okay. And this is to decide the sample size. Of course, one more sample is sometimes very costly, right? And of course, maybe very easy, right? Even it's very difficult, right? You see, now probably it's not that often, right? But sometimes you go to the near the subway station, right? There will be some people who try to collect data from you, right? Sometimes you do a survey or what, but or people calling the telephone, recording your phone, and then try to collect your opinion on certain stuff. That would be easily costly to get more data. Okay. So remember, this is the go back to the sample mean case. Okay, the population mean case. The margin of error, okay, is given by this formula, right? ME is equal to the standard deviation of the mean times the coefficient, right? Is usually 1.6, 1.9, and 2 point something, right? So the question is, okay, we want to achieve desirable margin of error, okay? Then what is N? Okay, suppose we know Z, okay? We know alpha, you know the ME, then we can calculate N, okay? So just to give you an idea, suppose I want to calculate the average income, okay, of whole Hong Kong, okay? Of course, if I have income from the government, then I'm done, okay? But we don't. So how do we do it is, suppose we know just suppose we know it. Okay, we want say 95% confidence. This is 1.64, right? And margin of error we decide. Okay, suppose we want to see, we want to estimate the income data. Okay, and with one margin error, like say within $1,000, right, or $2,000, this will be margin error, right? Because we learn to see left and right, and then we can calculate n. Okay, we put in this number can solve for n. Okay, but of course, you can easily see that this is same as this formula. How we do it, right, is by multiply both sides by root n, right? Move to the other side, and m equal down. Okay, and you square both sides. Okay, root n become n. This become this equation. Okay, and the last thing you look here is nothing but except you have this ceiling function. Okay, what's this is rounding up. Okay, because the inside, suppose what you get is 15.6. Okay, then you actually need 16 sample, right? If you have 16.1, you need 17 sample, right? If you have 69.5, then you need 70. Run up, right? So that's the formula here. Okay, see the example. This is nothing difficult, right? Because just instead of calculating this, given n, we're given m, you calculate n. Okay, just go a little bit backward, right? And look at this question. Okay, consider population with standard deviation 10. Okay, we don't ask how we get 10 here. Okay, just suppose we give 10. Okay, this is or some expert estimate. Okay, you can guess what it is. Okay, and what we want is at the end. Okay, we want to have 95% confidence interval. We want margin of error is 4. Okay, we need to decide our sample size. Okay, and we know 95% confidence interval. The z alpha 2 is 1.96. I'm not going to repeat that. Okay, the margin of error is 4. So the formula is like this, right? Is z square times sigma square over me square. Okay, just to remind you, this is the formula here, right? This is the c alpha over 2 square, right? And sigma square me square, right? So, and then you calculate is 24.01. Okay, unfortunately 01 there, so you go by 1. It's 25. Okay, of course you have 25, then usually what you get will be less than 4, right? But the required is within 4, so it's okay to be less than 4, right? It's okay to be smaller, right? So that is the idea how you decide how many samples you want. Okay, so if you have some idea that what should be the population deviation, then you can start the question. Okay, start to ask what is sample size. Okay, is there any question? If no, then we go to the next one. Okay. This one is very similar, right? Because this is just we talk proportion, right? Just replace just the same formula here, and you would multiply n. So this is the formula you have, right? Because you multiply root n to this side, and m is down and square. So this is the result. Okay. So let's see the example. Is very trivial. Suppose the historical evidence show the population proportion 0.4. Okay, and you are trying to do the same thing. Okay, first you calculate pi times 1 up pi, which is 0.024. Okay, and then you just calculate the z is 1.96. Margin of error, right? So this will be the answer. Okay, So just to remind you the formula again, in case you are reading this, right? So it will be just z alpha over 2, right? Square pi 1 minus pi over me square. Okay, so that would be 1.96, right? 0.4, 1 minus 0.4. This is me is 0.1 square. Okay, you can see the answer is 92.19. Okay, so we need 93 to make sure that the data, the sample you got is sufficient for our purpose. Okay. Now, you may ask, okay, the proportion, I use 0.4. How can we get this number? Okay. So luckily, one of the good things about this is the proportion is always between 0 and 1. Okay. And remember the sample proportion is what we use here is pi times 1 minus pi. Okay. So we actually have some idea for this. Okay. Actually, we have one good thing is pi times 1 minus pi. Okay. This looks like this. Pi. This is pi times 1 minus pi. This is 0, and this is 1, and this is 1/2, and this is 1/4. Right? So when pi is 0, this guy is 0. When pi is 1, this is 0. And pi is 1/2, this is the highest, is 1/4, right? Probably you know this is an inverted U-shape because this is a quadratic function, right? So you can see if we don't know pi, okay, what we're going to do is we're going to do the most conservative estimate, make the pi times 1 minus pi the biggest, okay? If you don't have any idea, it's 0.4. So take 1/2, okay? Take 1/2, consider 1/2, okay? So basically what we are saying is if we don't know the population proportion, okay, we'll do the following. And just use pi is 1/2, okay, because this guy is the largest, and it doesn't really matter what actually pi is, we estimate anyway. But using this, we try to collect a sample, then we always get what we want. Okay, so that's why when we have a political or opinion pool, okay, then actually we don't really worry about the outcome is fairly accurate. Okay, look at this again. So suppose we don't know what's population proportion, okay? We want to determine the 95% confidence, okay? The proportion is between 1%, okay? So the idea is again the same. If we don't know, we just put pi is 0.5, okay? Because this is the worst scenario, okay? And the rest will be the same, okay? And at the end, what you get is around 100 sample. Okay, so so that's why at least, okay, to be a 100 number. Okay, so if you want it to be between like 5%, right? Say 0.05, right? Then you more or less like 4 times more, so like 400 to 500. Okay, and then you want it to be within 2%, then it's more like 1,000 number. Okay, what I mean is here I have so what happened if we have 0.05? Okay, then you replace this by 0.05. Okay, what's this number? It's around 400 something. Because this is square, so it's just 4 times more. Okay. And if you have a 0.025, right, that's more like 800. Okay. And if you want to be 0.0125, right, it's more like 1,600. Okay. So if you want to be within 1%, also you less like you need around 1,000 to 2,000, around 2,000 number, right? So that's why you can see in the US when they look at the poll, look at the US election or political poll, usually they have 2,000. Okay, 1,015. So it's like 1,500 to 2,000, right? The reason why is here. Okay, it's always the number you need. Okay, you form 95% confidence, and this is sufficient, right? Usually 1% is fairly accurate, right? So that gives you an idea if you want to collect data for proportion data. If you want to have 1% accuracy, you need more or less 95% is more like 1,500, 1,600. Okay, so that is a explanation of why you see in the real world people do that. Okay, this is exactly fit what you see in the news. Okay, so for the remaining timing, I think we have half an hour. We are going to work on Excel and R on this chapter. Okay, so but before we start, any question? Any question? Okay, so what we are going to do is try to put your hands on, give you the raw data, okay, and then we do estimation. Okay, but before we start, let's talk you two. First, I tell you first thing. I told you the first thing. Okay, this is norm. Okay, and confidence norm. Okay, is giving you the margin of error ME. Okay, ME depend on alpha, sigma, and n. So this confidence dot norm, you give the alpha, sigma, and n, you calculate this for you. Okay, then you ask what is this, all right? And this is, you can calculate it. Okay, it's just the norm, right? As inward 1 minus alpha over 2, right? And times sigma times square root of n. Okay, so I'm trying to show you this expression is same as this expression. Okay, because this is margin of error. So let me first show you this is the calculation for the margin of error first. Okay, so we have the 5, 4, 64. Okay, first we do the following. Confidence norm. What's the number there? 105, 4, 64. Okay, so this is the confidence. Okay, so we want to show you this exactly same as I have claimed above. Okay, so this is exactly same as the following. Norm dot s dot inward. Okay, 5 divided by 2. Sample size is 4. Okay. Okay. And times sigma, which is 4. Okay. And divided by square root of n, which is 64 here. Okay. You will see that the same. Okay. This is the margin of error, right? Z alpha over 2 times sigma over root n. Okay, so these two are the same. Now, I hope that's okay. Let us actually, is that okay? Is that okay? Is there any question? If no, then let's us actually start from doing something real, okay? So consider the data, okay? Now we have some, maybe some GPA data, okay? Maybe GPA data, okay? What we're going to do is to ask GPA for everyone, okay? And then we calculate sample mean, okay? Of course, I'm not asking everyone, but let's assume we have some data here, right? Maybe the first guy is 2.7, the other guy is 3.6, and the guy is 3.5, and 3.1, and 3.4, okay? And maybe the last one is 3.3, okay? So this is the supposed GPA of the data we have, okay? I just randomly make up something, okay? Of course, in the real world, you just actually collect it, okay? Not generate by your head. And then you want to estimate what is the average GPA in this class, okay? Or suppose you want to measure GPA for, say, those students who major in accountancy, or more, or those who are doing quantitative finance, for example, okay? So what is the mean, okay? Because the first estimate, or we call X bar, okay, and say, right, or we call X, doesn't really matter, but just to make it easier for you to connect the notation, right? The first thing for you to do the X bar is the unbiased estimate, right? So that would be the sample mean, that will be average, okay? So this is unbiased estimate, right? Suppose you want to guess what would be the average GPA for this particular population, okay? So what you get is 3.3, not 3.326, okay? So this is the first thing you do, okay? The next thing you want to do, maybe I want to have is the, I want to know whether we know sigma, okay? Suppose we have sigma, okay? With the first case, suppose we have sigma. So what's the sigma, okay? Sigma is something we input, okay? Maybe just someone, I asked the university, they told me the sigma is like 0.2. I don't know. That may be a good estimate, or I don't know, but this is something given. So the blue one is something given, okay? It's not something from the model. So we have sigma of 0.2, okay? So what we want is to do the following, right? Alpha is what is the percentage, right? We want 95%, so alpha is, say, 5%, okay? So this is, we have this number tells us we want 95% confidence, okay? Now, we can calculate margin of error, okay? How do we do that, okay? That's, we can do it confidence norm, right? Alpha SD. Oh, I forgot one thing. Before we do it, we have one more n first, okay? N will be number of data. So we use a function called count. Okay, count how many of them. The count will give you number 66n, the sample size. Okay. So now we can use this formula, confidence norm, alpha, SD, okay, and the size. Okay. So this will be the confidence. Okay. And then you can calculate the upper confidence limit and lower confidence limit, right? So upper confidence, oh, I forgot to put the formula here. Okay. The UCL will be X bar plus the ME, right? The LCL will be X bar minus ME. Okay. So, sorry. So this, maybe I do it green. Okay. green, okay? So from this exercise, we start from the data. We make some entry sigmas given the data, okay? Someone gave us, okay? And we decide what's our alpha, okay? And maybe we also blue this one because the 2 is our input, okay? This 2 our input. And at the end, we want to know the green one, right? The X bar is 3.2, okay? And then based on this, okay, we are saying that the GPA will be between 3.1 and 3.4. Okay, so that is what we get. This is as confidence interval estimate. Okay, so now, is there any question? Now, suppose we do the following, okay? Suppose we no longer know the sigma, okay? This is something we don't know. Let me copy this again. Let me copy this to below, okay? Because what we're going to do is we don't use sigma anymore, okay? We use S because no one tells us what's going on here, okay? Suppose we don't know anymore. No one tells us this number, okay? We need to calculate this S, okay? And S is the STD S because the sample. Okay, so this would be our number here. Okay, and do note that the margin of error is no longer the norm. Okay, okay, that would be a little bit different because we need to rely on the following. Okay, we need the margin of error equal to confidence T. Okay. So we will use confidence T. So then this is our answer. I forgot should I use. Yes, okay, right. So this is the right formula. Okay, basically you change T to norm to T. Okay, so maybe I just show you what did I do in this one. So this is the ME based on this. This is this -1. Okay, maybe I just get it smaller. Okay, so are the data here, okay, and then I calculate the mean, the sample variance, right, and then I decide my alpha. I count how many n of them. Either I can put confidence, okay, which is I put my my alpha, my alpha, okay, and you will put the standard deviation. We put 60, right? I put n here, okay. So you will adjust T n minus 1 already. So with the calculator already take into account of n minus 1, okay. But this gives you direct margin of error. And then we just add and subtract, right? So we can see from this one, right? This range is much larger, right? Before we have, it's very accurate, right? Look at the above question, right? Suppose we know the standard deviation, right, is 0.2, is between 3.1 and 3.4. But now, if we calculate from the scratch, it's much larger. Okay. So actually, you need much larger data set, right? Number 6 is not good enough, right? Okay. So that's how we calculate that. Okay. Is there any question? Okay. To give you an exercise to do, let's do the following. Okay. Consider your binary data. Okay. We have 0, 1, 1, 0, 1, 0, or maybe 0 more. Okay. Okay. So what's this data? This data will be something like, do you like statistics? Okay. No. Yes. Yes. No. 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 Okay. So the question is, what I want you to do is you need to do the following, right? We need to calculate the P, right? Which is population proportion, right? And then we have the sample size N here, right? And then we have a margin of error here. We have UCL here and LCL here, okay? So let's do it. I give you 5 minutes. You can try to work it out, okay? This is sample proportion. This is a number of data. And then I want you to give me the margin of error, UCL using data. So this is the data. We start from scratch. We want you to work it out. Try to use the knowledge you learned from the class to handle what's the margin of error. Okay. Oh, I have to put the alpha, right? Alpha is put the alpha here. Okay. Alpha we can put 0.05 here. So for the margin of error, you can either calculate from scratch or you can do direct calculation. That's fine. So just to give you some hint, the point estimate, which is P, the sample proportion, it's just the sample mean, right? Just average. So okay. So I left you to fill in for the rest of the data. After this class is able to do it. If you're given data, you want to construct the point estimate, you want to construct a confidence interval, that you can do it. Okay. I hold your hand and you can do all the calculation by yourself. It's not something difficult. Okay. So the next step is count. Okay. This one is just count how many of them. This is the n. Alpha, you don't have anything there. Okay. So it's ME was ME there. So just to remind you what's ME in this case, ME, look at the formula, will be just C alpha over 2 would P1 minus P over N. Okay, so this is from your natural notes. Okay, there's nothing new here. So let's do it. Okay, how do we do that? Okay, so it will be just Z alpha over 2, right? We just norm. Okay, the two way to do it, I just do it directly. Then I will use this confidence norm. So this as inward, okay, alpha over 2. All right. Did complete the first part. Okay. The second part is a square root of the whole thing. So just square root of the whole thing. Okay. You have P times 1 minus P over N, just input directly. So just P times bracket 1 minus P, okay, divided by N. Okay, so this is the formula. Okay, this is this guy, right? The square root P 1 minus P over N. Okay, then oh sorry, 1 minus. Yes, so this would be the answer. Right? So, and that means that with this plus this guy, right? And LCL is this minus this guy. Okay. So of course, the lower confidence is a negative. It doesn't make a big sense, but this is what we have because P, the N is too small, right? You have very small sample size. So it's fairly inaccurate to say anything, but that's with the formula, okay? So for those who want to use the confidence norm, will be the following, okay? If you really want to use the confidence norm, that's not difficult, okay? Because you can write something called sigma, which is equal to P times 1 minus P, okay? And we take the square root, okay? You can look at this expression, this guy is sigma, okay? So if you want to do that, then you can put confidence norm. This is our alpha. This is our sigma. This is our size. Okay, you will see this have the same answer as before. Okay, but you need to calculate this first. Okay, of course, I prefer to do it directly, because it is directly from the formula, so we don't have to think. But if you really prefer to use the confidence norm, that's fine. Is that okay? Any question about the Excel? If no, we'll talk about R a little bit, but R would be similar. We don't have much thing to say because we don't have particular formula for R. Okay, I just show you the calculation. Okay, we are not really doing anything on R because there's no, for this simple thing, there's nothing, there's no special formula for R. All the formula following same as Excel. But is there any question before this? I go ahead. Any question? If no, then I would just show you the calculation for R because I don't want to make you late for the bus. Okay. So I hope this is okay. As I said, I upload this on the Blackboard once the class is over. So this is already shown here already anyway, but if you want to check, you'll be there. Okay. So at the end, what I want is to show you the R. Okay. I just show you for a time holder, I just show you for the mean, the proportion or T will be similar thing. Okay. So the data is here, X data. Okay. And what you are doing the calculation for the R will exactly same as Excel. Okay. Because there's no shortcut. Okay. Of course, you can write your formula, but here you can calculate N. I calculate sigma. I calculate SD. I calculate alpha. I calculate the width. Okay, the ME, and then this is the calculation. Okay, so let us copy this guy, and we go line by line for the formula. Okay, let's do it here. Okay, the first one is the data. Okay, you run it, the data. Okay. And this is length is same as a count in Excel, count how many of them, okay? And this is sigma is given by the data, right? And then you calculate the standard error, which is sigma over root n, okay? And then you calculate, alpha is given to you, okay? And you calculate this marginal error. This is not the width, but it's marginal error, ME, okay? The marginal error. And then our point estimate is maybe we call X bar. X bar is the mean of X. Okay. And then you have UCL is the X bar plus ME, right? You want to see what it is. And LCL is X bar minus ME, and you want to see LCL. Okay. So this, you run it, will be what we want. Okay. Just to repeat again, line by line, what I'm doing here. Line number 5 is data. Okay. Line number 6 is we do the number, how many of them, we just count. Okay. And in count it out, it's called length, it's just length of that. And line number 8, 9, and 10 is actually the confidence norm in Excel, right? What we're going to do is you have the sigma, the root n times the z alpha over 2. Okay. Remember the Q norm 1 minus alpha over 2 is the z alpha over 2. Okay. So that is the. Okay. This guy is z alpha over 2, right? And the standard error, you just, this guy, right? From up above is sigma over root n, right? So this is the clear margin error. And the X bar is the mean of X, right? The sample average. UCL will be X bar plus ME, and LCL will be X bar minus ME. So this is the calculation. Okay, so there's nothing. If you know the Excel, R will be straightforward. Okay, and I think you can easily change it to the when you don't know. Okay, so if you want to try, you go ahead and try. Okay, you can try the case where we have to calculate. You don't know sigma. Okay, let's do it. Okay, that's the last exercise of today. Okay, let's do this question without using the sigma. Okay, we need to calculate S and use QT, of course. Right, let's do that. You can copy this thing and then we change everything, right? Then you're done. Okay, same as how we do the Excel thing. Okay. Yeah. If you are in a hurry to catch a bus, you can just go, because I think this is very straightforward. But I left you the time. You can try a little bit. If you are on hurry, just go. So, because I will post the answer anyway on the web, but it shouldn't be difficult. The same idea for Excel. Yes.
Yeah.
We don't have computer, but we may ask you the command like what we do in the assignment.
Like the
Yeah, not the format. But I think we are open, so it doesn't really matter. So I guess, yeah, I think no difference. Right? Yeah, you don't have to memorize, but you don't have computer. I think you may bring the laptop, but I think you may bring the iPad, but I don't know. But iPad I don't, but the laptop I thought probably not, because yeah, it's very difficult. It can be a lot of cheating may happen, but you can have your phone. I think it's fine as long as you are the safe the flight mode. I think it's fine. Yeah. So if you want, you can do it. I will show you the answer. But if you hurry, you can just go, because I don't see this a very difficult exercise. So for those who are in a hurry, I just show you the answer before I discuss. So sigma, we will be doing SD of X. Okay, so everything will be same. S, okay, QT, and -1. Okay, so that everything will be the same. So the only changes is here. Is QT, this guy, and this guy. Okay, this is the only three places we change. If you change from sigma to S, right? Just replace it with that. Okay. Have fun. I will see you on Wednesday. So if you don't understand, you can ask me. I can help you. Otherwise, it would be. 唔係星期四係喺都係呢度，不過喺下邊。我哋冇電腦室，電腦室係需要一個非常強大嘅定房房嘅，唔係咁會訂到。So I'll stay around to answer any question you may have, because we booked the room until 11:30. So if you have anything, you can ask. Otherwise, then remember to log off your login.
That's all.